Hi. In this session, we're going to look at adapting our database logins as we move from a client-server application to an installable cloud application. So first of all, we have a disclaimer, and let's look at the agenda. So I'm going to talk about myself for a little bit, just so you know who I am. We're going to look at where we go about configuring these database connection caches. Then we'll look at the three different options: the static cache, the dynamic cache, and then dynamic connection. And then we'll compare the options, see what some of the advantages and disadvantages of the various options are. And then I've got a demo. Then we'll have Q&A. So a little bit about me. I've been using PowerBuilder since actually version 1. A few other things I'm fluent in: Oracle, PL SQL, Java, C#, C++. I've been doing, I've been helping with a couple open source projects. The two notable ones would be PBNI SMTP, which allows you to send SMTP emails from PowerBuilder using a PowerBuilder native interface extension. And the other one is back in version 10 of PowerBuilder, Sybase open sourced PowerBuilder Foundation class libraries, and I'm one of the people that helps maintain the open source project now. This is the company I work for since 2004, and if you want to know more about us, you can check on our website. Anyway, so let's look at how we configure the connection caches. If you go to your PowerServer project you're using to create your C# code and deploy your client, there's a Web API tab. At the bottom of that tab, there is a database configuration button. And that brings us up to this dialog. And there's several sections here. There's the cache group. There is the cache name. This is where you actually define the caches at. And then if you're using static mapping, there is a transaction to cache mapping that you would also populate. So at a minimum, you're going to need to have some caches defined. And then if you're using dynamic or pass-through, you would just use that information. And if you're using static, you would use the mapping down below here. Okay. If you open up the definition of one of those caches, you'll see that there's this option here that says allow dynamic connection using the transaction log, SQL ID, and log pass. So what that means is when you're using static caches and dynamic caches, in both cases, when you're connecting to the database on the server side, it's just going to take whichever cache that you're using and connect to the database using that cache, using the login ID and password that are defined in the cache. But if you have this option enabled here for dynamic connections, then what's going to happen is it's actually going to look at the login ID and password that are on the transaction object in the PowerServer code, and it's going to use that to make the connection. So that's how you get a dynamic connection. Basically, it's a pass-through of credentials. The dynamic cache and the static cache don't do a pass-through of the user credentials. The dynamic connection does a pass-through. Where this information gets written out into the C# code is in the applications.json file. So you can see here that I've created a couple connection caches, one that I've called Pete and one that I've called Pete user. And that got generated from that dialog I showed you earlier. You could possibly go in and edit this information directly yourself in the applications.json file. The problem with that will be is the next time you go to you make some changes in PowerScript and you regenerate the C# project, by default, PowerBuilder is going to overwrite that applications.json file. Now what you can do is in the project, you can uncheck this option here. And if you do that, that means that your applications.json file will not be affected then by the redeploy. Alternatively, what you could do is copy off your applications.json file, or if you've got it in source control, you could go ahead and do your deploy and just revert the changes to the applications.json file. Okay. So let's look at the static cache first. It's the easiest. So what you're going to do is you're going to create a connection cache. And this dialog is the definition of that cache right there. And you see you're providing a user ID and password. You don't have this option selected, so you're not allowing the dynamic pass-through, which means this is the user ID and password that will be used by the server-side code to connect to the database when that connection cache is used. And then what you do here is in the transaction to cache mapping is you indicate that whenever a transaction object called SQL.ca is being used, then it will use this particular cache. And so it's all handled automatically. Anytime the server-side code sees SQL.ca being used, it will automatically just use this connection. If you had, for most applications, that's going to cover it. There's very few applications that actually use more than one transaction object. If you do, you could create several caches and then several mappings, and mapping each transaction to a cache. Okay, dynamic caching. The difference here, well, there's some similarities. First of all, the similarity is that we are not going to check the option for dynamic connection. Once again, we're still going to use the user ID and password that's been defined in the connection cache on the server side. We're not going to use anything that's applied to the transaction object, at least for user ID and password, in PowerScript. What we don't have, this is the difference, is we don't have that transaction to cache mapping. This means that when you want to use one of these caches, you need to indicate in a dbparm setting which one of those caches, or you could have more than two, obviously, but which one of those caches that you would want to use. The scenario I'm looking at here is I'm going to say I've got two roles for users. Either they're a viewer or there's somebody who can view and update. And so I call the user the one that just can view, and the one that can update I call PM, project manager. And what I could do on my client side is look to see who the user is and determine whether they're just a viewer or if they're allowed to update, and then dynamically assign the connection cache as the user is being logged in to the application. Now, this is an example of how you would do the dynamic cache. So here we have a dbparm. Now, to be truly dynamic, well, this is somewhat dynamic, but to be truly dynamic, you would do this in PowerScript, not in the ini file. Or we'll get into some scenarios much later on where you might actually do this in the ini file. But you could do either one. So you have a dbparm, and what you add is at least one, if not both of these parameters. The one that's optional is the cache group. If your cache group is the default cache group, you don't have to supply the cache group. I've done it here just to show you how it's used. But the cache name is required. So here, in this case, I'm assigning that project manager cache to the transaction. And so that's the connection that will be used. Once again, it doesn't matter what you have here for login ID and login password, though, because it would appear that would still be in the server in the PowerScript. So if you had PowerScript that was running that was trying to use security like the PFC security classes, that could look at the login ID that was either put here or was supplied by the user during their login. but it would not be seen server-side. What would be seen server-side is what's used in the definition of the cache. Okay, this is the third option. This is the dynamic connection. This is where we do specify that a dynamic connection is allowed. And so we could do this with dynamic or static mapping of the cache. But the important thing here is we've checked this option that allows the pass-through, which means that we can, when we populate SQL.ca and we put in a login ID and a password on SQL.ca, that actually gets used server-side. Okay, so that's probably makes a little bit more sense if you're just coming straight from client server, because that's the way your client server app operates. It uses normally 95% of those apps out there use the database account for the user and authenticate the user by connecting using their account. So this would be the sort of the more natural way you would approach it as a coming directly from client server. It's not the best way to run the application though, because there's some significant performance issues with using the dynamic connection. Now we're going to cover that when we go into the options here. Okay, the first thing we're going to look at is security. The first two options, the dynamic cache and the static cache, are more secure than the dynamic connection. And the reason they are is because with the dynamic connection, you are passing credentials from the client to the server. And we're using REST methods now. And so it's possible that if somebody can intercept those calls, they can read that connection information from the client. Or you've also got INI files that you may have the connection information in as well. So it's only as secure as your least secure client. Whereas with the dynamic cache and the static cache, the connection information is defined in the server, and so it's just more secure there, because you don't have to worry about your least secure client. All you have to do is worry about how secure the server is. The dynamic cache is a little bit more secure because you can define database caches with different database permissions. As I gave in that example earlier, where I had one cache for somebody who had only read privileges and another cache for a person who had read and write privileges. If I'm dynamically assigning the caches to the appropriate users, that means if somebody who only had view permissions somehow got into a window that allowed them to edit, they still couldn't change anything because I've logged in with an account that only gives them view permissions in the database. So that's that. Now we're going to look at performance. Oops, sorry, I went a little bit too far. We'll talk about performance, and this is what I was indicating a little bit earlier, where I said the dynamic connection, while it may seem more native to you coming from a client-server perspective, is not necessarily the place you eventually want to end up. The reason, and this is typical for most web applications, is that most web applications will create a set of connection caches on the server that they use to connect to the database. And remember, we're not making SQL calls now, at least not from the PowerBuilder client. We're making REST calls, and REST calls are stateless. So every time a REST call is made, what the server is going to do is it's going to grab a connection off the connection cache and connect to the database. And it can keep doing that without reconnecting to the database, because this connection cache is using the same user ID and password for all the connections in the cache. It's not tied to the user. It's just an account that can be used to interact with the database from the server side. So that saves a lot of the disconnect logic that may be required. If you go to a dynamic connection where you're passing in the username and password, then every time you make a REST call, the server is going to have to disconnect and reconnect to the database because it doesn't know that the user ID and a password that were on that connection originally are necessarily going to be the same as what it's going to make for the next call. So what it's going to do is end up disconnecting and then reconnecting on every REST call. And that's going to be a pretty big performance hit. And that's one of the reasons you might want to think about moving away from a dynamic connection and authenticating the user differently than you are currently doing it. Not using the database login for your user authentication. And that actually gets us into the next topic. When you're using the dynamic cache and the static cache, once again, the client, the login ID and password on the client, the power of the client, can be the user. But the login ID on the server side is going to be whatever was used for that cache. It's not going to indicate who the user is. Whereas for a dynamic connection, they're the same on both the client and the server. What that means is that if you're going to use a dynamic cache or a static cache, it doesn't really matter so much on the PowerScript side because it still represents the user. So if you got things like the PFC security service in use, that would still be appropriate. That would still work correctly. However, database code that references user ID information from the connection, let's say if you've got a trigger that is doing auditing and it uses the user ID from the connection to indicate who the user is, that code is not going to work anymore because all of that user ID is going to tell you is that it was somebody using the cloud app. It wasn't a specific user. So what you're going to need to look at is an alternative means of letting your database know who the user is for each particular call. You might pass it in on as a parameter to the REST call. So the database, if you're doing things like auditing where you need to know who the user is, where it would use that to get the user information rather than trying to use the user ID on the connection. And this is the other thing I was alluding to. If you go to a static or dynamic cache, the connection isn't based on user credentials. So it's generally going to work regardless of what's on the login ID and login password, which means that you're no longer authenticating the user against their database account. If you use the dynamic connection, that still works. You do authenticate the user based on the login ID and login password. But if you go to a dynamic or static cache, you're going to need to look at a different means of authenticating the user other than whether or not they connect to the database. One approach is to create a table in the database that has the user ID and an encrypted password, and then when the user logs in, go ahead and look in that table for the user ID and the server side's code would unencrypt the password so that it could validate the password was correct. That's one approach. The other thing you might want to look at is moving to third-party authentication. And I have a whole separate session here at Elevate on third-party authentication. It's a pretty broad topic, and I'd rather, if you're interested in that, recommend attending that session or going and doing that session later. There is one other option, but I would consider it only suggest considering it in the short term, and that's using essentially a merged or mixed type of mapping of connections. What you could do is you could have a connection that's going to be the connection pool, and use that for SQL CA. Use that for the 99 to 95 to 99% of the database code that interacts with the database. But I would also then have a separate transaction object where you allow a dynamic connection. And so what you could do in your login is you take that second transaction object and you actually log the user in to the database using that, and that would then authenticate them against the database. So you know that the user is valid. Once you know the user is valid, you disconnect that connection, throw it away, and then allow the user in, but you haven't allowing them to use SQL CA. So that means that you don't have to immediately refactor your database authentication. That's one way to do it a little more quickly. But the longer, I'd recommend the longer term approach, though, is to actually re-architect the application so that you're not using a database account to authenticate the user. And there's other good reasons for doing that. One of them is that many enterprise databases bill according to the licensed user count in the database. Well, once you move to the web and you're using a connection cache that's all using the same user ID, you dramatically reduce the number of named users in your database, and that could save you significant money depending on your licensing terms. I mentioned some additional uses that you might have for dynamic mapping. One of those is if you have a development, test, and production databases, and you want to switch between them rather easily. One way you can do that is by creating development, test, and production caches in the configuration, and then using the dbparm setting to switch between them. So you don't have to embed all the connection information in the INI file in the client and switch and keep changing it out. You define that all in your profile, in the connection profiles, and have that server side, and then just toggle between them when using dbparm. And the second scenario is very much like that. Instead of having different environments, you might be an ISV that's hosting an app for a large number of customers, and they each have their own database in your environment. And so you'd want to log each set of users for each customer into their own database, and you could do that as well through dynamic mapping using the dbparm. Okay, enough of that. Let's go ahead and do a demo. Okay, for the first sample, what I'm going to show is static cache. So if I go to the Web APIs tab, you'll notice that there is a cache name here, and it does not allow dynamic connection, and it's mapped to SQL CA. So anytime SQL CA is referenced in the application, it's just going to automatically use a connection based on this cache name, and it's going to use the user ID and password that's defined in that cache, not what's put on SQL CA. And what I've got in this sample code, it's a little convoluted. I have an INI file where I pass in the authentication. So for this demo, it'll be static cache, dynamic cache, and dynamic connection. And then in the login code, there's an earlier section that reads the INI file and gets most of the connection information. And then it reads that setting from the INI file, and then it branches to different functions based on whether it's a static cache, dynamic cache, or dynamic connection. And then here, this is the static cache where I'm actually doing nothing. You know, your application's not going to look like this. I just put this together to show all the different approaches. The reason I'm not doing anything here, once again, is to remember we've static mapped the connection and we're not using the user ID and password. So there's really nothing to do with this connection. A little bit later on in our login method, it does the SQL CA connect using whatever it's got. Okay, so let's go ahead and run that. And what's going to happen here is, unfortunately, unless I put in some other authentication method for the user, such as the table with the encrypted password that I mentioned before, or a third-party auth provider, I can type anything in here, and it will let me in the application. So that's the one downside you have to watch out for. But that is the static cache. So the second option we're going to look at here is the dynamic cache. We look at the web APIs here, and you'll see that there are caches defined. Those caches, once again, do not allow dynamic connection, but you notice there's no mapping. So what we have to do is, in our code, is map SQL CA to one of those caches. And the way I've got this defined, these different caches use a different username password combination to represent different roles. One thing I'll note here if you go look at the sample code is I have the solution name mapped to different solutions, and that way it kind of keeps at least the C# code segregated so that things kind of map up correctly. But the one thing you have to do is you have to make sure you go into the INI file and change this to the authentication to whichever mode is correct for that project. So that is set to dynamic cache. Let's go ahead and run this. Oh, before we run that, let me go ahead and show you the function that I'm using here for the dynamic cache. So now I am using the user ID at least to confirm or to assign the appropriate connection cache. But once again, unless I create that table, it's got user IDs and encrypted passwords or a third-party auth service, some other outside means of authenticating the user. All they have to do is actually just get the username correct. The password's not being validated. So let's go ahead now and there we go, and run that. So I'll put in, I still can put in a garbage password, and it'll let us in. But I do have to get the username correct. And once again, if you're going to want to implement some sort of independent authorization of the user other than database connection, if you're going to use the static or dynamic cache approaches. Okay, so this is the third option. This is the dynamic connection. If I look at my database configuration, I can see that I've created a definition of a cache. When I look at the cache parameters, I do have the dynamic connection enabled for this one. What I don't have is a mapping. Okay, which means I do have to map it dynamically in the PowerScript. And if we look at the function that I'm using for dynamic connection, we can see that I'm doing that, but I'm also passing in the user ID and password, because that actually will override what's on the connection cache definition. And so we do get the user validation using their user ID and password. But it does also mean that all the REST calls will have to disconnect and reconnect each time that a call is made. So if we go ahead and run that, and I put in a correct username but a bad password, let's see, I will get an error message. But if I run that and put it in correctly, then I'm allowed in. Okay. If you play with the sample code and you don't get the results you expect, make sure that what you have in for the authentication method matches the particular project you're working with, because otherwise the configurations of the caches won't be consistent, and you won't get the results that I'm showing here. And now let's cover the questions and answers.